Hi everyone, this is Sahiti on behalf of Edureka, and I welcome you to this first live session on microservices with Spring Boot. Since it's the first live session on microservices, I'm going to keep it really simple so that you understand the basics of microservices, and in the further sessions coming on microservices, we'll get into the in-depth concepts of it, right? So first of all, I thank all the attendees for joining in today's session. Before I get started with the session, can I get a confirmation on the chat window whether I'm audible or not? Alright, so meanwhile, let me tell you that, Edureka has reached around 500,000 subscribers on YouTube. So folks who have participated in the Edureka fan video contest, stay tuned for the results which will be announced soon. Right? Alright, so many of you have sent me a confirmation. Alright, so that's great. So now let's get started with the session. So without wasting any further time, let me take you through the topics of today's session. So I'll start today's session by telling you the history behind microservices, that is what architecture existed before microservices came into the picture. Once you understand this, I'll tell you what are microservices and explain you its architecture. After that, we'll look on to the advantages of microservices, where you will understand how the challenges faced by the previous architectures were overcome with this. And then, since the session is with microservices with Spring Boot, I'll just introduce you about Spring Boot and finally end this session with a hands-on part. Alright, so is the agenda clear to everyone? Alright, so that's great. So now let's get started with the session. So now before microservices came into the picture, there was something known as the monolithic architecture. In this type of architecture, basically the entire software is composed in a single piece that is designed to be self-contained. So what I mean by that is all the components of the monolithic program are interconnected and are interdependent. So in other words, you can say that it will give you a tightly coupled software wherein each component along with its associated components must be present in order to execute or compile the code. So all these components are actually dependent on each other. So if you notice the definition on the front of your screen, it says that it's like a big container wherein all the software components of an application are assembled together and are tightly packaged. So as you can see the example on the screen, it consists of a server-side application which will execute the domain-specific logic, and also at the same time it will populate the HTML views sent to the browser. So it's basically happening all together, right? So this particular application is handling so many functionalities together, and this application is not divided into small services, but everything is tightly packaged together, right? So in such scenarios, even if one component fails to work, then the complete architecture breaks down and fails to work. Now, none of us would want our architectures or applications to break down and not work, right? So the same was the scenario with eBay. As all of us know that eBay is a hyper-growth company and it adds around 300 features per quarter. These features are then trained and are shown on the eBay website, wherein millions of users use it together. But with such load on website, when hundreds or millions of users are using the features together, it may fail to work properly. If it's in a big container, if it's in a big container, that is the monolithic architecture. So to overcome this, eBay needed an architecture which could probably do proper load balancing and also make sure that that all its services, or you can say all the features, are working properly. So eBay decided to shift its monolithic architecture, which was initially developed on Perl, to C++. Then they started using Java to handle the complete architecture and finally shifted to microservices. Right? So now with this, you guys must have understood what is the need of microservices, right? It just came into the picture because we had to overcome the challenges of monolithic architecture. But what exactly are these microservices? Well, microservice is an architecture wherein all the components of the system are put into individual components which can be built, deployed, and scaled individually. So suppose if you have an application with n number of features, then you will be the one who will be able to decide how these features have to be segregated into individual services based on their functionalities. Now obviously I'm assuming that none of you must have understood with this technical terms of definitions, right? So let me just explain you with a simple analogy over here. So you must have seen how bees build their honeycomb by aligning hexagonal waxels, right? So they initially start with a small section using various materials and continue to build a large beehive out of it. Now these cells then form a pattern and result in a strong structure which holds together a particular section of the beehive. Now over here, each cell is independent of each other, but yes, it is also correlated with the other cells, which means that damage to one cell does not damage to the other cells. So bees can, reconstruct these cells without impacting the complete beehive. So even if, one particular cell does not work, then, bees can just reconstruct it. You don't have to, rebuild a complete beehive, right? So similar is the case with the microservices. So as you can see on the screen, each hexagonal shape represents an individual service component which is independent of the other services. So each agile team builds an individual service component with the available frameworks and the chosen technology stack. So by chosen technology stack, I mean that you can build all these individual services on various frameworks, such as service 1 can be built on Python, service 2 can be built on Java, service 3 can be built on Go, and so on. Right? Now, not only this, just as in a beehive, each service component forms a strong microservice architecture to provide better scalability. So by scalability, I mean that you don't have to scale all these services together. Suppose if you want to just scale service 1 and you don't want to scale any other service, then that's perfectly fine. You can individually scale that particular service. Also, issues with each component can also be handled individually with the agile team with no or minimal impact on the entire application. So suppose if service 4 goes down, then in any case the complete system will not stop working. Instead, only that particular service will not work and you just have to wait until that service starts working and it will work, right? So and what I'm trying to say is you just have to make sure that make sure that all your services are running perfectly. So guys, that was all about microservices. Now, have you thought of how these individual different components of microservice architecture work together, or how did eBay shift its monolithic framework into microservices? Well, to understand that, you have to know the components of microservice architecture which help these very large number of microservices to work together. So starting with the components of a typical microservice architecture, the components are the clients, identity providers, API gateways, messaging formats, databases, static content management, and service discovery. So the architecture starts initially with different types of clients from different devices trying to perform various management capabilities such as search, build, configure. Then these requests from the clients are passed on to the identity providers and who authenticate these requests of clients and communicate the request to the API gateway. So basically, these requests are then communicated to the internal services via a well-defined API gateway. Now, since clients do not call these services directly, API gateway acts as an entry point for all the clients to forward requests to the appropriate microservices. Not only this, but API gateway also ensures that all the services can be updated without the clients knowing. So these services basically use message protocols which are not web-friendly. Now, after receiving the request of clients, the internal architecture consists of microservices that we discussed before in the session that I just mentioned, right? And these services communicate with each other through messages to handle client requests. Now, talking about messages, there are mainly two types of messages, that is the synchronous messages and the asynchronous messages. So synchronous messages are used in the situation wherein clients wait for the responses from a service, and microservices usually tend to use the REST services as it relies on a stateless and a client-server HTTP protocol. This particular protocol is used as it is used in a distributed environment, and each and every functionality is represented with a resource to carry out the operations. Coming to the asynchronous messages are used in the situation wherein clients do not wait for the responses from a service. So microservices usually tend to use the protocols such as the AMQP protocol, STOMP, and MQTT. So guys, I'm not going to go into the depth of these protocols, but let me just tell you that these protocols are used in type of the communication since the nature of the messages is defined and these messages have to be interoperable between the implementations. Now, until now, I've told you that about clients, identity providers, and API gateways. So you've understood how requests come, how they get handled by microservices, and where and where all it is passed on. But have you thought of where does the data of all these microservices get stored? Well, each microservice owns a private database to capture the data and implement their respective business functionality. The databases of microservices are updated through the service APIs only, and the services provided by the microservices are carried forward to any remote service which supports inter-process communication for different technology stacks. So microservice 1 will have its own database, service 2 will have its own database, service 3 will again have its own database, and so on. Now, after each and every microservice communicate with themselves, they deploy the static content, that is basically any content that can be delivered to an end user without having to be generated, modified, or processed to a cloud-based storage service that can deliver them directly to the clients via the content delivery networks. Now, if you ask me about the content delivery networks, as the name suggests, they're basically a content distribution network which consists of a geographically distributed network of proxy servers and the data centers. Since each microservice owns their own private database and has individual functionalities which do not overlap from the other services, this network distributes the services to the end users to provide high availability and high performance. So guys, these were the main components of the architecture, but yes, there are also some other components such as the management and service discovery. Well, management is basically responsible for the service, for balancing the services on nodes and identifying the failures. So suppose with the management with the management component, you'll know which service is taking up which load or which service is currently running low. Right? Now coming to the service discovery acts as a guide to the microservices to find the route of communication between them, as it maintains a list of services on which nodes are located. So it will help the microservices to know which request has to be passed on to which service, and also how a request has to be passed on from one service to another service. Right? So guys, this was all about microservices and microservice architecture. I hope you guys have understood the basics of microservices. They're just really simple. They're just small services working together to build a big application, right? So now let me just brush you up with a few advantages of microservices. So starting with agility, by agility I mean that you can make changes to any one microservice. So suppose you don't want to change anything in any other service, but you want to make changes only in the customer service in this particular example that you can see on the screen, then this can be done really quickly. You don't have to change the product service or the cart service, as these services are independent of each other. So any change that you make to the customer service will not impact the product service and the cart service, right? So this will obviously decrease the deployment time also. Now moving on to the next advantage, that is scalability. By scalability I mean that you can scale any particular service without scaling the others that I mentioned before, right? So suppose if you want to scale only the customer service and you don't want to scale any other service by adding new features, then you can absolutely upscale or descale this particular service. You don't have to upscale or descale any other service to just scale the customer service, right? Now, not only this, I also want to mention another advantage, that is fault tolerance. So since microservice architecture has individual separate services, so separate services would make the application fault tolerant, as we can host that microservice on different server and manage load balancing. So suppose product service fails in any case, then the complete system will not go down. Instead, you just have to make that particular service work, and the system will work absolutely fine. Right? So these were a few advantages of microservices, guys. Now, as this session is about microservices with Spring Boot, let me just give you a little bit of information about Spring Boot, like what Spring Boot is and why do we need Spring Boot, right? So what exactly is Spring Boot? Well, Spring Boot is a Spring framework. It makes it easy to create Spring-powered production-grade applications, and it also takes an opinionated view of the Spring platform. Now, why do we need Spring Boot? Well, it provides faster and widely accessible getting started experience. It finds quick ways to diverge from the defaults. It also provides a range of non-functional features. And finally, it does not generate any code. So there's no XML configuration required at all, right? So with these advantages, we obviously need Spring Boot. right? So guys, now that you've understood, and maybe you've got a basic concept of what microservices are, how its architecture look, and what Spring Boot is, let's quickly jump on to our hands-on part, right? So in our hands-on part, I'm mainly going to deal with three services, that is the game service, gamer service, and the order service. So let me just open my Eclipse IDE now. So as you can see, I've created three Maven projects, that is the gamer service, game service, and order service. Now before I get into the depth of all these three services, let me tell you that you have to download the Spring Tool Suite from the Eclipse Marketplace. So for that, you just have to go to Help, go to Eclipse Marketplace. Okay, this is running slow, which is not expected, but yes, you have to type in Spring Tool Suite and you'll see an ID which can be installed, right? So let me just type in Spring Tool Suite. Okay, so you see that it is already installed on my system. If it's not installed on your system, just click on this install radio button and it will start getting installed, right? Now once you're done installing, Now once you're done installing this particular ID, you just have to close this Eclipse Marketplace and you have to start creating your own projects, that is the Spring Boot projects. So for that, you go to File, you go to New, you go to Other. Then over here under the Spring Boot folder, you choose Spring Starter Project. So once you select that, go to Next. And over here, you have to mention the project's name and all the other details. So let's say I mention the project's name to be Hello. And I want the type to be Maven, Java version to be 8, group ID to be com.example, artifact to be hello again, description to be it's a demo project, and package to be com.example.demo. Once I'm done with that, I'll click on Next. And over here, you have to mention all the dependencies that you require for this project. So let's say I just want the web and the jersey dependency. So I'll click them, I'll select them, and I'll click on Finish. So I'm not going to do that presently. So once you click on Finish, you'll automatically see that your project has been created. So let me just close that now. Alright, now coming back to our own microservices, that is the services that I've created. So I've basically three services, the gamer service, game service, and the order service. So coming to the gamer service, let me start explaining you with the POM file. So let me just open the POM file. So POM file is a file wherein you put all the dependencies of your project, right? So whatever dependencies I just show you how to mention, you can also mention it using this POM file. So over here I've mentioned the jersey dependency, the web dependency to create REST services and also to boot up the Spring parent, right? So similarly I've done it for the game service and also the order service. So let me just open and show you guys, right? So as you can see, I've mentioned the required dependencies. Now moving forward, let me open the classes and show you. So over here I'm going to start with the gamer service. So in the gamer service, I've created an application.java file. So let me just open that and show you. Well, this application.java file is basically works like an initiator to the Spring Boot, which is defined obviously with this particular annotation, that is Spring Boot application. So this works as an initiator to the Spring Boot. Since it is an initiator to the Spring Boot, I've kept it common, that is identical in all the three services. So all the three services have this particular file. So let me just open that and show you again. So as you can see, there's no difference between the application file of all the three services. Now moving on to the next file, that is application configuration.java. Well, I've created this file so that we mention the REST services. So I've added this annotation @configuration to indicate to the framework that it is a resource configuration class. I've also set up the jersey configuration, which is basically a resource manager responsible for exposing the REST services for application consumers. Now what I mean by application consumers, I'll let you know very soon. So but this file is going to be common in our gamer service and the game service. So let me just open and show you. Well, as you can see, this is our file for the gamer service and this is our file for the game service, and yes, it is common, right? Now coming to the order service, this file is going to be a little bit different. So that's because this that's because the order service is the consumer service. So as I was mentioning before, this particular service is the consumer service. So when I say it's a consumer service, it will include all the parameters of the gamer service and also the game service. So don't worry guys, when I run this projects, you'll understand what I'm talking about exactly. So because of that, I've included the REST template instantiation also. So this is basically one of the basic ways, or you can say standard ways in Spring Framework that facilitates the consumption of the REST services, right? So this is how this file has a difference in the order service. Now I'm going back to a gamer service. Let's go to the other files. Okay, so I have a gamer.java file. So in this file, I'm basically, giving all the parameters that I want as an output. So I want the gamer ID, name, and gamer email ID. And for that, I've initialized the getter setter methods. And similarly, I've done it for the games also. Let me just open and show you. So when you go to the game.java file, I've mentioned the game ID, game name, rating, genre, platform, publisher name, right? So I've mentioned again, I've initialized again the getter setter methods, and the same is the scenario with the order, but we'll come to the order service later on. And coming back to the gamer service, let's go to the gamer rest.java file. So over here at the starting, I've mentioned the part to be backslash, right? So that's because when you go to the allocated port of this particular service, then you just have to mention the port number and you'll get in all the details of the gamers, right? Whatever I've mentioned in this file, right? So you'll get in all the details of all these particular gamers. Not only this, if you want the information of any one particular gamer, let's say I want the information of gamer 10 with the ID 10, right? So I'll just mention this gamer ID and I'll get the information of this particular gamer. So when I run the project, I'll show you how that's happening. Now that is done with this particular query over here, and when I run this file, it will give an output as a JSON file. So similarly, again, let me go to the games rest.java file. So again, I've mentioned the path. So that means whenever I go to the port to which this particular service is allocated, it will give me all the details of all the games that I've mentioned over here, and it will produce again a JSON file. Not only this, if you want to find out the information of any one particular game, then you just have to mention the game ID, right? Now coming to the order service, let me open the files for you. So as you can see, we have the game.java, gamer.java, order.java, order rest, and also package, right? So basically, you must be wondering, right? Why have I put the gamer.java and game.java files over here? That's because these are not classes. These are not direct. I'm sorry. These are not just direct references of the classes implemented in the other projects, but these are classes that I've cloned from these services, right? So this particular class has been cloned from this particular service, and gamer.java has been cloned from the gamer service. Now let me just open the order.java file. So in the order.java file, I've again mentioned all the details I wanted as an output. So I want the order ID, amount, and order date. And yes, I also want the gamer details and the game details. So by this, I'll come to know which gamer has ordered which game, on what date, and how much amount has he paid, and what is his order ID, right? So for that, I've again, initialized the getter setter methods, as you can see. Now going to the order rest.java file. So over here, I've mentioned the part to be order. So when I go to the port to which this particular service has been allocated, I'll mention in the part order, and then I'll mention the gamer ID, game ID, and the amount. So when I mention this particular parameters, what I'll get is what gamer, or you can say which gamer has ordered what game and how much amount has he paid. So you'll get in all the order details, right? So with that, I've mentioned over here through which the order service will take in the data of all the gamers and the games. So this was all about the services, guys. Now if you want to run these particular services, you all obviously have to allocate the ports, right? So for that, you'll right click on these projects, go to properties, go to run debug settings, go to gamer service, and go to arguments over here, and over here you'll type in the port. So I've typed -d server.port is equal to 8086. So for gamers, I've mentioned the port as 8086. For games, I've mentioned the port as 8087, and for orders, I've mentioned the port as 8089. So let me just show you. So as you can see, for gamers, for games, I mentioned the port as 8087. And for orders, I've mentioned the port as 8089, right? So that's how you configure your REST services. Now once you're done with that, you just have to run your projects as Spring Boot app. So for that, you'll again right click on this project, go to run as, and choose Spring Boot app. So when you run this project, you can see that Tomcat has started on the port that you've allocated. So I've just run the gamer service, so it's allocated on 8086 and the application has started. So similarly, let me run the game service also. So you can again see that the game service has started on port number 8087 and the application has started. And let me run the order services. So it has started on port number 8089 and again obviously the application has started, right? So that means our services are running perfectly fine. So let me just go and check. So let's open a web browser. Okay, so let me just reload this port. So as you can see, when I reload this port on 8086, I get all the details of all the gamers, that is the name, ID and the email IDs, right? So I've mentioned around 10 gamers, so I've mentioned all the details for them. Then when I go to port number 8087, let me just reload again. So you'll see you'll get in all the details of all the particular games, right? All the game details that we have mentioned in our REST services files. Now, if I want to find out the information of any one particular game, let's say I want to find the information of this particular game. So I'll copy this ID. I'll go to localhost port 8087 because that's the that's the port wherein the game service runs, and I'll mention the ID over here. So you can see that the output shows in JSON file that this particular game ID has rating of very positive, genre, platform, publishers names, and also the name of the game, right? So similarly, if I want to find out which any particular gamer with a certain ID, I'll go to port number 8086 and let's say I mention the ID to be 5. So you can see the details of the gamer with ID 5. Now let's go to our consumer service, that is let's go to the port number 8089 and let's see how it runs. So in the path I've mentioned order and I've mentioned gamer ID. Let's say I mentioned gamer ID to be 2. Let's say ID game to stand the same and amount to be around 2300. Right? So when I load this page, you can see the details that the order ID has been generated as 1, the amount he has paid is 2300 that I just mentioned, the order date has been generated with this particular gamer's complete information and the game's complete information, right? So you must have understood, right? So the game service and the gamer service are collaborating with each other to give an output to the order service. So the order service is basically a consumer service through which we're getting all the information of the gamers in the game. So with this particular output, you'll understand which gamer has ordered which game and what is his order ID, what is the amount he has paid, and what is the order date, right? So you get all the details. So guys, this was a short demo on microservices so that you get an understanding of how microservices work together, how they collaborate with each other. Well, you can get it into the depth of microservices that we'll be seeing in the further sessions. Now if you want now let me tell you that if you want the projects, you can comment out in our comment sections, and this brings to an end to our session. So before I end this session, let me just tell you that Edureka offers live training which will help you gain expertise in developing a microservice architecture based solutions. So this will let you learn how to apply microservice principles to a specific business requirements to build a scalable and a performing solution. After completing this particular training, you will have a gain knowledge about various microservice architecture styles and also how to select appropriate architecture design. So we'll start with the course curriculum. So the course curriculum starts with evolution of microservices, which will basically talk about the history of microservices. Then we'll get into the microservice architecture, which will tell you about different aspects of microservice architecture, what it is, how can it be done, what are the deep components of it, how does each and every service communicate, and so on. Then we'll understand the designing principles, security principles, testing principles, and finally you'll you learn the complete architecture with a reference architecture, that is with the Netflix reference architecture. So you'll understand how Netflix works on this microservices framework, and then you'll gain the expertise to build your own microservice architecture, right? So guys, that was an end to our this session. I hope you found this session informative. So I hope you guys are waiting for more sessions on microservices to come up. So thank you and have a great day.